Hi everyone, we live in the most interesting era of space exploration. The James Webb Space Telescope is one of the reasons for that. The James Webb Space Telescope, or JWST in short, is a space telescope that was launched on December 25, 2021. It is the most powerful and advanced space telescope ever built, and it is designed to observe the universe in the infrared spectrum. This is the first part of my James Webb Space Telescope Appreciation series. In this video, we are going to visit the alluring Moon Europa, the outer planets, gas giants Jupiter and Saturn, and ice giants Uranus and Neptune through the eyes of the James Webb Space Telescope. But first, a little about the James Webb Space Telescope. The main scientific goals of the fascinating telescope are to study the first stars and galaxies that formed after the Big Bang, the evolution of galaxies over time, the formation of stars and planetary systems, and the atmospheres of exoplanets. James Webb Space Telescope is already making groundbreaking discoveries. For example, it has recently detected the most distant galaxy ever seen, and it has also detected water vapor in the atmosphere of an exoplanet. James Webb Space Telescope is a truly revolutionary telescope, and it is expected to make many more important discoveries in the years to come. It is a testament to human ingenuity and our desire to explore the universe. Here are some of the key features of the James Webb Space Telescope. It has a primary mirror that is 6.5 meters in diameter. This is the largest mirror ever used in a space telescope. It uses infrared detectors to observe the universe. This allows it to see objects that are too faint or too distant to be seen by visible light telescopes. It is positioned in an orbit around the Sun, about 1 million miles from Earth. This position gives it a clear view of the universe and protects it from the interference of Earth's atmosphere. James Webb Space Telescope is a collaborative project between NASA, the European Space Agency ESA, and the Canadian Space Agency CSA. It is one of the most expensive and ambitious scientific projects ever undertaken, but it has the potential to revolutionize our understanding of the universe. Let's start our journey from the big brother of our solar system, Jupiter. Jupiter is the largest planet in our solar system and one of the most interesting. It is a gas giant with a thick atmosphere and a strong magnetic field. Jupiter is also surrounded by a system of rings and moons. With giant storms, powerful winds, auroras, and extreme temperature and pressure conditions, Jupiter has a lot going on. Here are some of the reasons why Jupiter is so interesting. Size and mass. Jupiter is the largest planet in our solar system, with a mass that is more than twice the mass of all the other planets combined. This makes Jupiter a very powerful object in the solar system. The atmosphere. Jupiter has a very thick atmosphere, which is made up mostly of hydrogen and helium. The atmosphere is also very stormy, with winds that can reach speeds of up to 400 miles per hour. The Great Red Spot. One of the most distinctive features of Jupiter is the Great Red Spot. The Great Red Spot is a giant storm that has been raging on Jupiter for hundreds of years. The ring system. Jupiter has a ring system, which was discovered in 1979. The ring system is made up of dust particles, and it is relatively young. Moons. Jupiter has a system of 79 moons, which is the largest moon system in our solar system. Some of the most notable moons of Jupiter include Ganymede, Callisto, Io, and Europa. Jupiter is also a very important planet for our understanding of the solar system and the universe. Jupiter's gravity helps to keep the solar system stable, and it also plays a role in the formation of stars and planets. NASA's James Webb Space Telescope has captured new images of the planet. Webb's Jupiter observations will give scientists even more clues to Jupiter's inner life. James Webb Space Telescope's near-infrared camera, NIRCam, captured this image of Jupiter, showing its auroras, rings, and moons Amalthea and Adrastea. NIRCam has 3 specialized infrared filters that showcase details of the planet. Since infrared light is invisible to the human eye, The light has been mapped onto the visible spectrum. Generally, the longest wavelengths appear redder and the shortest wavelengths are shown as more blue. These are the most detailed pictures of the planet we have. Remarkably, we can see details on Jupiter together with its rings. In the standalone view of Jupiter, created from a composite of several images from Webb, auroras extend to high altitudes above both the northern and southern poles of Jupiter. The Great Red Spot, a famous storm so big it could swallow Earth, appears white in these views, as do other clouds, because they reflect a lot of sunlight. The brightness here indicates high altitude, so the Great Red Spot has high-altitude hazes, as does the equatorial region. The numerous bright white spots and streaks are likely very high-altitude cloud tops of condensed convective storms. By contrast, dark ribbons north of the equatorial region have little cloud cover. In a wide-field view, Webb sees Jupiter with its faint rings, which are 1,000,000 times fainter than the planet, and two tiny moons called Amalthea and Adrastea. This one image sums up the science of our Jupiter system program, which studies the dynamics and chemistry of Jupiter itself, its rings, and its satellite system. Researchers have already begun analyzing Webb's data to get new scientific results about our solar system's largest planet. Before going on the long trip to Saturn, let's make a quick stop at the most interesting moon in our solar system. Europa is one of the most interesting moons in our solar system. It is one of the 4 Galilean moons of Jupiter and is the 6th largest moon in the solar system. Europa is thought to have a subsurface ocean of liquid water, which makes it a prime target in the search for extraterrestrial life. Here are some of the reasons why Europa is so interesting. Potential for life. Europa's subsurface ocean is a habitable environment, meaning that it could potentially support life. The sea is rich in nutrients, and it is also thought to have hydrothermal vents, which are known to support life on Earth. Unique geology. Europa has a unique geology, with a surface that is covered in ice and water vapor. The ice crust is several kilometers thick, and it is cracked and fractured. This suggests that Europa's subsurface ocean is actively interacting with the surface, which could create conditions favorable for life. Potential for future exploration. Europa is a relatively easy moon to reach, and it is possible to land a spacecraft on the surface. This would allow scientists to study Europa's subsurface ocean and its potential for life in more detail. NASA is currently developing a mission to Europa called the Europa Clipper. The Europa Clipper is scheduled to launch in 2024, and it will study Europa's subsurface ocean and its potential for life in great detail. Thus, it is easy to understand why this is one of the most important projects the James Webb Space Telescope is focused on. On request of Samantha K. Trumbo from Cornell University, James Webb Space Telescope pointed its NIRCam and NIR spec to Europa from the 9th of November 2022 to the 23rd of November 2022. In the compositional maps, the white pixels correspond to carbon dioxide in the large-scale region of disrupted chaos terrain known as Terra Regio, center and right, with additional concentrations within portions of the chaos region, Paus Regio, left. The second and third panels show evidence of crystalline carbon dioxide, while the fourth panel indicates a complex and amorphous form of carbon dioxide. Astronomers using Webb have found carbon on the chaotic terrain of Terra Regio and Paus Regio. Surface ice in these regions has been disrupted, and there likely has been a relatively recent exchange of material between the subsurface ocean and the icy surface. Carbon, a universal building block for life as we know it, likely originated in Europa's ocean. The discovery suggests a potentially habitable environment in the salty subsurface ocean of Europa. Let's move on to the pretty lady of the solar system. Saturn is the 6th planet from the Sun and the 2nd largest planet in our solar system. It is a gas giant with a thick atmosphere and a strong magnetic field. Saturn is also surrounded by a system of rings and moons. Saturn is one of the most interesting planets in our solar system for several reasons. Here are just a few. Its rings. Saturn's rings are one of the most iconic features of the planet. They are made up of billions of pieces of ice and rock, ranging in size from tiny dust particles to boulders. The rings are thought to have formed from the breakup of a moon or moons early in Saturn's history. Its moons. Saturn has 82 known moons, the most of any planet in our solar system. Some of the most notable moons of Saturn include Titan, Rhea, Dione, Tethys, Enceladus, and Iapetus. Titan is the largest moon in the solar system, and it is the only known moon with a dense atmosphere. Enceladus is thought to have a subsurface ocean of liquid water, which makes it a prime target in the search for extraterrestrial life. Its atmosphere. Saturn has a very thick atmosphere, which is made up mostly of hydrogen and helium. The atmosphere is also very stormy, with winds that can reach speeds of up to 1,100 miles per hour. Its magnetic field. Saturn has a very strong magnetic field, which is generated by the movement of liquid metal in the planet's core. The magnetic field is tilted at an angle of 11 degrees relative to the planet's axis, which is another unusual feature of Saturn. Saturn is a fascinating planet with a lot to offer. It is a giant planet with beautiful rings, a variety of moons, and a thick atmosphere. Saturn is also an important planet for our understanding of the solar system and the universe. In addition to that, Saturn is also interesting because it is one of the most dynamic planets in our solar system. Saturn's rings are constantly changing, and Saturn's atmosphere is very active. Saturn's moons are also very dynamic, with Enceladus constantly spewing water vapor into space, and Titan having a weather system that is similar to Earth's. Saturn is a truly amazing planet, and it is one of the most important targets for future space exploration. On June 25, 2023, NASA's James Webb Space Telescope turned to the famed ringed world Saturn for its first near-infrared observations of the planet. The initial imagery from Webb's NIRCam is already fascinating to researchers. Saturn itself appears extremely dark at this infrared wavelength observed by the telescope, as methane gas absorbs almost all of the sunlight falling into the atmosphere. However, the icy rings stay relatively bright, leading to the unusual appearance of Saturn in the Webb image. This image was taken as part of Webb's Guaranteed Time Observation Program 1247. The program included several very deep exposures of Saturn, which were designed to test the telescope's capacity to detect faint moons around the planet and its bright rings. Any newly discovered moons could garner important clues about the flow of material in the current Saturn system, as well as its history. Next on our journey is Uranus. Following in the footsteps of the Neptune image released in 2022, NASA's James Webb Space Telescope has taken a stunning image of the solar system's other ice giant, the planet Uranus. The new image features dramatic rings as well as bright features in the planet's atmosphere. Uranus is the seventh planet from the Sun and is the third largest planet in our solar system. It is also one of the most interesting planets, with several unique features. Here are some of the reasons why Uranus is so interesting. Axial tilt. Uranus has a very unusual axial tilt, with its axis tilted at an angle of 97.77 degrees relative to the plane of its orbit. This means that Uranus spins on its side, with its poles pointing directly at the Sun for half of its orbit and directly away from the Sun for the other half. This extreme tilt is the result of a collision with another large object early in the solar system's history. Rings. Uranus has a system of rings, which was discovered in 1977. The rings are very faint, and they are made up of dark, rocky particles. The rings are also very dynamic, and they are changing shape and size over time. Moons. Uranus has a system of 27 known moons. The largest moons of Uranus are Titania, Oberon, Umbriel, and Ariel. These moons are thought to have formed from a disk of material that surrounded Uranus early in the solar system's history. Atmosphere. Uranus has a thick atmosphere, which is made up mostly of hydrogen and helium. The atmosphere is also very cold, with temperatures that can reach as low as -224 degrees Celsius. Magnetic field. Uranus has a strong magnetic field, which is to be generated by the movement of liquid metal in the planet's core. The magnetic field is tilted at an angle of 59 degrees relative to the planet's axis, which is another unusual feature of Uranus. Uranus is a fascinating planet with a lot to offer. It is a giant planet with a unique axial tilt, a system of rings and moons, a thick atmosphere, and a strong magnetic field. Uranus is also an important planet for our understanding of the solar system and the universe. In addition to the above, Uranus is also interesting because it is one of the least explored planets in our solar system. Only one spacecraft, Voyager 2, has ever visited Uranus, and it only flew by the planet once in 1986. This means that we still have a lot to learn about Uranus, and future missions to the planet could make many important discoveries. Uranus has never looked better. Webb's first glimpse at this ice giant highlights bright atmospheric features, as well as 11 of the planet's 13 rings. Only Voyager 2 and Keck, with adaptive optics, have imaged the planet's faintest rings before, and never as clearly as this. Uranus rotates on its side, causing its poles to experience 42 years of sunlight and 42 years of darkness. It takes 84 years to orbit the Sun. When Voyager flew by Uranus in 1986, it was summer at its south pole. Currently, the south pole is out of view, facing the darkness of space. Check out the polar cap, bright white area, on the right side of the image. Webb reveals a subtle enhanced brightening at its center. This polar cap appears in the direct sunlight of summer and vanishes in the fall. Webb's data will help us to understand this mystery. This was only a 12-minute exposure image, and it's just the tip of the iceberg for what Webb will uncover. When Voyager 2 looked at Uranus, its camera showed an almost featureless blue-green ball in visible wavelengths. With the infrared wavelengths and extra sensitivity of Webb, we see more detail, showing how dynamic the atmosphere of Uranus is. On the right side of the planet, there's an area of brightening at the pole facing the Sun, known as a polar cap. This polar cap is unique to Uranus. It seems to appear when the pole enters direct sunlight in the summer and vanishes in the fall. These Webb data will help scientists understand the currently mysterious mechanism. Webb revealed a surprising aspect of the polar cap, a subtle enhanced brightening at the center of the cap. The sensitivity and longer wavelengths of Webb's NIRCam may be why we can see this enhanced Uranus polar feature when it has not been seen as clearly with other powerful telescopes like the Hubble Space Telescope and Keck Observatory. At the edge of the polar cap lies a bright cloud as well as a few fainter extended features just beyond the cap's edge, and a second very bright cloud is seen at the planet's left limb. Such clouds are typical for Uranus in infrared wavelengths and likely are connected to storm activity. This planet is characterized as an ice giant due to the chemical makeup of its interior. Most of its mass is a hot, dense fluid of icy materials, water, methane, and ammonia above a small rocky core. Uranus has 13 known rings, and 11 of them are visible in this Webb image. Some of these rings are so bright with Webb that when they are close together, they appear to merge into a larger ring. 9 are classed as the main rings of the planet, and 2 are the fainter dusty rings, such as the diffuse Zeta ring closest to the planet, that weren't discovered until the 1986 flyby by Voyager 2. Scientists expect that future Webb images of Uranus will reveal the 2 faint outer rings that were discovered with Hubble during the 2007 ring plane crossing. Webb also captured many of Uranus's 27 known moons, most of which are too small and faint to be seen here. The 6 brightest are identified in the wide view image. This was only a short, 12-minute exposure image of Uranus with just 2 filters. It is just the tip of the iceberg of what Webb can do when observing this mysterious planet. In 2022, the National Academies of Sciences, Engineering, and Medicine identified Uranus science as a priority in its 2023 to 2033 Planetary Science and Astrobiology Decadal Survey. Additional studies of Uranus are happening now, and more are planned in Webb's first year of science operations. Our last stop on our journey is on Neptune. Neptune and its rings shine in this infrared image captured by the James Webb Space Telescope and released by NASA on September 21, 2022. Not since Voyager 2 flew past Neptune in 1989 have the planet's rings been revealed in such clarity. 6 small moons near the planet are visible, while Triton shines brightly to the upper left. The icy moon reflects an average of 70% of the sunlight that hits it. Let's focus on those beautiful rings. Neptune's rings are important for several reasons. They provide clues about Neptune's formation and evolution. The rings are relatively young, and they are thought to have been formed from the collision of 2 moons or the breakup of a larger moon. By studying the rings, scientists can learn more about how Neptune formed and evolved. Neptune's rings are one of the most dynamic ring systems in our solar system. The rings are constantly changing, and they are influenced by Neptune's moons and by the gravitational pull of other planets. By studying Neptune's rings, scientists can learn more about how rings form and evolve in general. They provide a unique perspective on Neptune's atmosphere and magnetic field. Neptune's rings interact with the planet's atmosphere and magnetic field in ways that are not fully understood. By studying the rings, scientists can learn more about how Neptune's atmosphere and magnetic field work. Neptune's rings are one of the most beautiful and fascinating features of our solar system. By studying the rings, we can learn more about the beauty and complexity of the universe. In addition to these general reasons, Neptune's rings are also important because they are one of the few ring systems in our solar system that is known to interact with moons. This could also provide clues about the potential for life on Neptune's moon Triton. Neptune's rings consist of 5 principal rings: Gale, Leverrier, Lassell, Arago, and Adams. They were first discovered in 1984 by André Braix and William B. Hubbard's teams at La Silla Observatory and Cerro Tololo Inter-American Observatory in Chile. Neptune also has a faint, unnamed ring coincident with the orbit of the moon Galatea, and 3 other moons orbit between the rings: Naiad, Thalassa, and Despina. The rings are composed of at least 20% dust, with some containing as much as 70% dust, while the rest of the material comprising the rings is small rocks. The other 5 known rings of Neptune, Gale, Leverrier, Lassell, Arago, and Galatea lack the non-uniformity in density exhibited by Adams. NASA's James Webb Space Telescope shows off its capabilities closer to home with its first image of Neptune. Not only has Webb captured the clearest view of this distant planet's rings in more than 30 years, but its cameras reveal the ice giant in a whole new light. More subtly, a thin line of brightness circling the planet's equator could be a visual signature of global atmospheric circulation that powers Neptune's winds and storms. The atmosphere descends and warms at the equator, and thus glows at infrared wavelengths more than the surrounding cooler gases. Neptune's 164-year orbit means its northern pole at the top of this image is just out of view for astronomers, but the Webb images hint at an intriguing brightness in that area. A previously known vortex at the southern pole is evident in Webb's view, but for the first time, Webb has revealed a continuous band of high-latitude clouds surrounding it. Webb also captured 7 of Neptune's 14 known moons. Dominating this Webb portrait of Neptune is a very bright point of light sporting the signature diffraction spikes seen in many of Webb's images, but this is not a star. Rather, this is Neptune's large and unusual moon, Triton. Covered in a frozen sheen of condensed nitrogen, Triton reflects an average of 70% of the sunlight that hits it. It far outshines Neptune in this image because the planet's atmosphere is darkened by methane absorption at these near-infrared wavelengths. Triton orbits Neptune in an unusual backward orbit, leading astronomers to speculate that this moon was originally a Kuiper Belt object that was gravitationally captured by Neptune. Additional Webb studies of both Triton and Neptune are planned in the coming year, thanks to the James Webb Space Telescope for this journey. In the future, Webb will solve mysteries in our solar system, look beyond to distant worlds around other stars, and probe the mysterious structures and origins of our universe and our place in it. We have much of the universe to understand, and the James Webb Space Telescope is here to help us. Thanks for coming on this visit with me. Until next time, keep looking up.